Hello, my name is Scott Mesjian, and today I'll be doing an explainer video for problem 14 of chapter 16. What are the amplitude, frequency, and wavelength of the wave in figure example 16.4? And here we have this graph of a wave. So our goal is to find the amplitude, frequency, and wavelength of this wave, and it gives us a little extra information that the wave is also traveling to the left at 2 meters per second. Um, so first of all, I guess we can look at the amplitude. So we know amplitude as being the distance from um, equilibrium to like the max displacement. So that'd be from like any point here in the center to the maximum it goes away from um, 0. So I guess in that case, as you can see, it just goes up to 6. So the amplitude is just 6. And in this case, you can see it's centimeters, so it's 6 centimeters, or I guess 0.06 meters, either way. For the frequency, well, we know frequency is related to 1 over the period. And period is just the distance between two two humps or two crests or two uh, drops. I forget what they're called, but so we're just going to take this section as the period. So here we can see it goes from uh, 0.02 to point 2 to point 0.8, sorry, and that's in seconds. So you could just subtract that, I guess, and then you'll get 0.6 seconds. From there, you can just plug in to get the frequency. So you'll just do 1 over 0.6. Pretty simple, not too tricky for that one. That'll just give you, that's doing this in fractions. I guess you could say that 4 or 0.6 is also equal to, oh, I'm sorry, not 4, 6 over 10 or 3 over 5 as well. So then if you invert that, that's just 5 over 3. And we know that is 1.67 1 over seconds, or you could say 1.67 hertz for the frequency. And that little last part just got a little complicated, but that's just because I didn't want to use a calculator. Sorry about that. But okay, yeah, for the wavelength, this is the only, you could say tricky part, I guess. All you have to do is make use of this formula. Um, the velocity of the wave is equal to the frequency times the wavelength, or yeah, the velocity is equal to the frequency times the wavelength. So we know the velocity is 2 meters per second, and we also know now that the frequency is 1.67 hertz. So if we just rewrite this in terms of wavelength, we can solve for it since we know the other two variables. So wavelength is equal to velocity over frequency, and that's just 2 over 1.67, and I believe that is 1.2, um, and that's just meters because you had meters per second and then 1 over second. So yeah, that's just it. It's a pretty simple problem.